Hey everybody, this is Alex Merced, developer advocate here at Dremio and your host here every week on Gnarly Data Waves. And this week, I will be presenting about ETL, ELT, and the Dremio Lakehouse. So we'll go over what ETL, ELT is, make sure we're all on the same page, and then we're going to just talk about sort of like how Dremio can facilitate both patterns and, basically address sometimes a lot of the challenges in both different patterns. So we'll go through that. But before we do all that, of course, I'd like to remind you guys to go try out the Dremio Lakehouse. Go head over to dremio.com, click on the test drive button. No cost, no obligation. Get to try out working with Dremio so that way you can see what Dremio brings to the table and what it means to have use the Dremio Lakehouse platform. And Dremio, we try to be everywhere and anywhere at all times. So we're going to be at all these events coming up. So Big Data and AI in Paris in September, Big Data London this month in September, Coalesce DBT in October, and me and Dipankar, the developer advocates here at Dremio, we're going to be doing an Apache Iceberg Ask Me Anything over there at Data Day, Texas in January. Okay, so you'll be able to come down in person, ask us anything you want. We'll also be doing office hours while we're on site over there. Yeah, it's going to be a good time kind of celebrating being near the release of the Apache Iceberg Definitive Guide at that point early next year. And on that note, again, my name is Alex Merced. I'm a developer advocate here at Dremio, and we're talking about ETL and the Dremio Lakehouse. But a little bit about who I am, if you're not as familiar with me. I've worked in data, I've worked in web for companies like Crossfield Digital, Campus Guard, General Assembly. I'm one of the co-authors of Apache Iceberg, the Definitive Guide, which I mentioned earlier. I've spoken at many events like P99 Conf, Data Council, Data Day Texas. I run several podcasts, which I'll mention again in a minute, written different libraries for Python and JavaScript. I like code, I like tech, I like talking about tech. That's essentially the long and short of it. And on the note of the book, if you want to get an early copy of the book, so right now I think it's about like 160 or even 180 pages that are available in the early release. So lots of information already available to you about Apache Iceberg when you get that early release copy, which just got updated last week. So if you've done it like a month ago, you got the early release copy, go pick it up again because there's new chapters there. Okay, and you just have to scan that QR code right there and you get a free copy. Also, I mentioned that I host some podcasts. So you guys are here already on Gnarly Data Waves, which we do every week. But I also do Select Star from Data Lake with Dipankar Mazumdar. We're the developer advocates here at Dremio. And then I do a solo podcast called Data Nation. All of these can be accessible on Spotify and iTunes. So subscribe. And, we always got stuff to say. We always got all sorts of interesting things going on in the data world. And now we will begin with our featured presentation talking about ETL, ELT, and the Dremio Lakehouse. And again, throughout the presentation, if you have any questions, okay, just put them in the chat. Okay. And we're going to talk about, again, ETL, ELT, and the Dremio Data Lakehouse. So first off, we're just going to kind of go over what these things are, just to make sure that we're all on the same page. Okay. And essentially, first we'll go over ETL. ETL is sort of a pattern that has been around forever when it comes to taking data from point A and moving it to point B. Essentially, what we do is you'll have a source of the data, which could be like a transactional database or could be an IoT device, but you have somewhere where data is coming from. We're going to take the data out of that place, but what you're going to do is you're going to transform the data in the process of moving it. So that way you structure it to however you need it for your analytical needs in the destination. So let's say you're landing it as Parquet files in Amazon S3. So essentially, the data would come from, let's say, a Postgres database. You might change the schema. You might denormalize some tables. Whatever other transformations you might decide that you want to do some data quality checks, clean up bad records, backfill things, make all these transformations so that way basically the already curated data is landing in those Parquet files in S3. So the idea is that the transformation is happening before the data arrives at its location, not after. That's going to be the key distinction between the two patterns. So what are the pros and cons of this? So when it comes to ETL, some of the benefits, the pros of taking the ETL approach is data quality control. Because in this case, I'm doing all of that work before the data lands. So that means the data can land in exactly the way I want, and I could have pre-checked it for things like null records, referential integrity checks. All these things could have been done in that transformation process before the data lands. So you have more data quality assurances of the data that landed in your destination, whether that's the data lake or a data warehouse or wherever. Performance. Okay. Since the data transformation occurs before loading, there's no transformations that have to occur after. Ideal world. So in that case, when you're querying the data, you're just basically querying the data as it is. So you're not also spending time doing additional sort of like schema transformations or other transformations in those final queries. So it can, especially for like larger data sets, can improve performance. Okay, structured data works really well for structured data. Okay, because at the end of the day, what you're doing is you're trying to refine the structure in that transformation process. Okay, but there are some cons, okay, to doing sort of like an ETL approach. Latency, okay, because you're doing the transformation in between the landing, that means like the actual moving of the data is like two things. You got to actually like load the data or export the data, and then you have to also wait for the transformation. So there's a lot more computing that has to be done in that process. It can take longer, and that can create latency for people who want to query that data where it lands, because it's not arriving there as fast as it would have if it wasn't transformed in that step. So there's a latency consideration. There's complexity. Okay, so basically that one step is doing all the work. You saw all the logic for how do I get the data out of the location, and what do I do with the data to transform it before I land in the new locations, all being done in one job or in one process. Okay, so in that case, there's a lot more complexity of that process. And basically, as you scale it up, basically where you're starting to deal with more and more data and more complex transformations, it gets it can get harder to scale. Okay, so again, just since it's doing more, there's just more work to do when you're scaling that leg of the journey. Okay, so that's sort of the ETL story. There are some best practices you can follow. Okay, so such as data profiling. Okay, it's much easier to design these jobs well. Okay, if you spend some time just kind of learning the data before you build the job. So profiling the source of data, making sure you understand what's sort of the existing structure, like where's it starting and where is it supposed to end, and having a sort of a kind of mapping out sort of the beginning end process, essentially like pseudo code when you're writing code, just kind of thinking through what is it that I'm trying to do before you go and execute. So creating those data profiles so that way you can go through that sort of logical layer, that logical process before you go through the implementation. Okay, incremental loading. So this is like things like CDC, using ways to sort of capture the changes in the data. So that way, as data changes, you're not having to reload the full data set, but just the incremental changes to speed up the process of doing those jobs. And then monitoring and logging. So that way you have logs that you can use to kind of pick up on any errors or unexpected behavior. And then monitoring so that way you have some sort of way to actually seal this information to get an idea of the health of your pipeline. Okay, so that's sort of the ETL side. So again, ETL, we're taking the data out, transforming it, then landing it. Okay. And then data lineage, you want to keep track of sort of, and that's going to be a best practice regardless which way we do this, that you keep track of sort of how the data got from point A to point B. And there's going to be different mechanisms for doing that. But then there's also ELT. Okay, so in the ELT story, basically what you're doing is you're saying, you know what, let's not transform the data right away. I'm just going to export the data. I'm just going to move the data from point A to point B. So I'll just take it out of that. I'll just take those raw tables out of that Postgres database. I won't denormalize them. I won't make any changes to their schema, at least not yet. And then I'm going to land them in Parquet files in S3, and then I'll let the processes going forward to transform them, which could be, maybe you have logical views that basically do those transformations on a per query basis, or you create other physical copies of the data post that. So you'll take the Parquet files and then transform them into other Parquet files with your transformations applied. But the idea is that it's after sort of that initial load. So you're initially loading essentially the raw data and then transforming from there. Okay, and then again, this can have some pros and cons too. I mean, sort of right off the top of my head, I'm thinking, okay, well, it is possible that you might end up storing more data because you're just storing the raw data. You might have, data you might have not loaded through that would have been lost through data cleanup or data validation, stuff like that. It is going to sort of be in that sort of that raw landing zone. And on top of that, depending on where you're doing the transformations afterwards, you may be doing them in a more expensive place. So let's imagine a scenario where we're applying ELT to a data warehouse. So the idea is you may be taking the data from your data lake, the raw data from your data lake or your Postgres database, and directly loading it into a data warehouse in a bunch of denormalized tables. So now all that normalization that you might do, all this additional transformation work is going to be done with the warehouse compute, which may be more expensive. So then essentially you're doing those transformations with more expensive compute, which can then, well, increase your costs. But there are, again, pros and cons to this approach. And then again, you'll see later on that like Dremio does a lot to kind of help enable this to be even, especially the ELT part, to be more practical and not hit those sort of cost problems. So pros of ELT, flexibility. Okay, so in that case, I don't have to commit to how I'm transforming my data up front. I just get my data, let's say, into the data lake, land them in Parquet files and iceberg tables, whatever form you want, and then I can transform them from there. Okay, I don't have to necessarily make that commitment up front, so it's a little flexible. I can make changes. It's scalable because basically each leg of the journey is kind of doing less work, so it's easier to kind of think through the scaling issues. It's easier to think through two simpler jobs than trying to think through one complex job and how to scale that and how to make that work and meet SLAs. Real-time analysis, essentially, since the data is going to land there faster, people who are using sort of like that raw data or who can use that raw data to do their analysis can, well, get there faster because they don't have to wait as long for those transformations to happen. Okay, cons of ELT. Data quality. Again, you're loading the raw data, so you haven't done any of those data quality checks. So again, that could, if people are using that raw data for analytics, that could, well, cause problems. Performance, okay? Now this is more performance on the query side versus on the ingestion side. So basically here we're having a faster ingestion because we're not doing those transformations in the ingestion, but we might be doing them on our queries because we might be doing those transformations through sort of logical views. And now those logical views are doing those processes and doing that compute at that time. And again, that gets more expensive if you're doing it using data warehouse compute, which oftentimes is marked up from just pure cloud compute. Okay. So then you're paying, whatever your cost of your AWS or your Azure instances, plus whatever the markup of the data warehouse is for that compute. Okay. So best practices for ELT. Okay. It's basically schema on read. So essentially what's going to happen is that regardless of what the data currently looks like in the Parquet file, you can have, and this is what happens when you're using something like Apache Iceberg, where the schema is technically tracked in the metadata. And then I've been writing Parquet files to that iceberg table for a long period of time. The schema may have changed. So the schema technically of the table is different than, let's say, the original handful of Parquet files that were written because the schema has changed. But what happens is it implements the schema of the table on the data regardless on that read, because the engine will say, okay, hey, based on the iceberg metadata, this is the schema. So regardless of what the Parquet files, regardless of the structure of the Parquet file, I'm going to make sure to return the data matching the schema as it was in this snapshot. So things like Apache Iceberg kind of help make that schema on read type approach doable. Okay, metadata management, maintain metadata to track data transformations and ensure data lineage. Again, this is another place where Apache Iceberg is really going to be sort of really helpful. And then Dremio actually has data lineage built into its semantic layer. So in that case, if you were to do ELT with Dremio, basically once you land your raw data in the data lake, all the transformations going forward could occur on the Dremio platform through different through different views or creating new tables, however you would like. And then all of that would be the lineage of how you get from point A to point B will all be visible on the Dremio platform. So when you're doing ELT, it actually allows you to kind of really capture that full lineage from the moment you've landed the raw data to whatever views you provide your final end user. Okay, data governance. Establish data governance practices to monitor and improve data quality. But bottom line is you want data quality checks. You want to make sure that the right people have the right access to the data. So that way, as you land all this raw data, you're not accidentally exposing any data you don't want. Since you're not, cleaning up any PII ahead of time or doing any of that stuff, you're just landing the raw data. Okay, but either approach, basically, bottom line is, especially if you're using sort of cloud infrastructure, you have three areas where your costs are kind of coming from. Storage. Okay, so the more data I store, the more that I spend. Okay, compute. Okay, the longer those instances are running, to compute those queries, running whatever software they're running, whether they're running Spark, whether they're running Dremio, whether they're running any other miscellaneous proprietary compute software for running queries, you're paying for those instances. So basically, the faster the queries can be done, the less time those compute instances need to be active, saving you money. Okay, so if I can store less data, if I can compute less, also if I can access less, because you're also going to get charged for all those API calls to S3. So not only are you paying for the physical storage, but the access of that data. And then there's also egress costs if you're moving it out of the network. So there's all these different places where you may get hit with costs depending on, if you don't intelligently plan sort of how you set everything up and take advantage of a lot of these innovations that can optimize these costs. Okay, and just kind of reiterate it again, when you're doing something like, let's say you're using X data warehouse, you're paying a markup to that compute. So basically, and then if you're landing particularly if you're doing like ELT into a data warehouse, you're landing the raw data. So you might be landing more data in the data warehouse. So you're paying for storage that's marked up. And then you're doing the transformations in the data warehouse. So then you're paying for compute that's marked up. And generally the data warehouse compute is going to be marked up more. Okay, so you're paying for that sort of premium price to do things that you could have done for less had you done them, let's say done ETL, where you would have transformed that before you're landing it in there, where you maybe just be paying for the pure compute cost, depending on what platform and what tools you're using for that data integration. Okay, and so bottom line, possibly more expensive compute. So when you're using like ELT, possibly. But again, I will show you that ELT can be done in a very affordable way when we use Dremio. Okay, now if the destination is the data lakehouse, so again, if you're using Dremio as your data lakehouse platform, okay, the raw data and transformed data exists on a lower cost data lake. So bottom line, you're just paying for that pure S3 storage cost, which is going to be cheaper. Okay, if you're using Dremio, okay, as your engine, if you're using Dremio Community Edition, whatnot, you're not paying any additional costs other than the instances that you're deploying. Okay, and then generally if you're using sort of the Enterprise Edition or Dremio Cloud, the markups over the compute are going to be less so than the data warehouse. So you're using cheaper compute. You're going to use cheaper storage. So if you are doing either pattern, the cost is going to be overall, if that becomes the center of your analytics, basically the center of your analytics universe. Okay. And the thing is that you don't have to transform things like right away. So for example, you land raw, you don't even necessarily need to move data, because with Dremio, you can federate that data. So like, for example, if I have tables in Postgres, okay, I can just, instead of having to export all those Postgres tables and then land them over there as iceberg tables in S3, which may be something I want to do depending on different factors. But depending on the details, I may not want to. I may not need to. It may be good enough for me to just connect Postgres to Dremio, okay, and then I can access those tables. And then if latency is an issue, accessing the Postgres table directly for your analytical needs, Dremio has a feature called data reflections. And essentially, when you turn on data reflections, it essentially does create sort of an iceberg table under the hood that is physically represented. But you don't have to worry about you don't have to come up with that pipeline that keeps that in sync, that every time that Postgres table changes, the reflection updates. It will, and then also your end users don't need to think about that there's a separate copy of the table. They would just query the Postgres table, and then Dremio would then use the data reflection to actually process the query performantly. And then again, Dremio will handle the logic of making sure that it always matches and regularly updates it to match that Postgres table. So then you take a lot of that sort of like, you make it more user-friendly for the end user and also easier from the pipeline perspective, where the reflection becomes your pipeline in that kind of sense. And again, lower cost storage, lower cost compute relative to, landing raw data in a warehouse and then doing your transformations from there. Okay, and again, because Dremio can federate all sorts of different sources, like even data warehouses, so you can connect your data from Snowflake and do this with Dremio, Delta Lake tables on your S3 or Azure, Postgres tables, MySQL tables, Iceberg tables, and then with Iceberg you have read and write, so you can then, you can actually handle some of your ETL work right there from within Dremio, and do something like, incrementally update an iceberg table using data from a Postgres table by doing like a select insert or an insert select statement. Okay. Data that's sitting on your AWS S3, your Azure Blob Storage. Okay. Google Cloud, Hadoop. All of these sources can then connect to Dremio. Okay. At that point, you've moved no data, so you have no cost at that point, as far as like compute to move that data or cost of storage for duplicating the data. And then you can curate logical views. Dremio is going to be a very performant engine, so a lot of the time, just the performance of Dremio will be enough. But in the situations that there isn't, so maybe because like the particular Postgres server that you're connecting to, or the particular MySQL server, the pushing down the queries there maybe cause some latency that you want to eliminate. You turn on data reflections, okay, and then data reflections again will periodically make sure that it syncs with that underlying source. And again, it's using Iceberg, and you're getting the benefits of Iceberg and its Iceberg metadata to speed up that process. And the other cool thing about reflections is that when you create these reflections, you can actually choose partitioning and sorting rules. So it may be pulling the data from the Postgres table, but it will sort it, it will partition it for you, so that way you get a very crisp representation that really gives you crisp performance. Now, what happens now then again, as your SLAs get tighter and tighter, okay, so then that's when you start thinking, okay, hey, maybe instead of using data reflections, I want to actually start landing my data directly into Iceberg. Okay, and then that's where you might want to use Dremio to take that data from the Postgres database, and then again through like create table as statements or select insert statements, you can then move that data over to an Iceberg table, in which case basically the refresh situation, basically you're always going to have the access to the freshest data, because basically the way Iceberg works is that it always refers to the catalog, so it's always grabbing the latest snapshot. But then you would have to kind of like set a schedule of, okay, we're going to do these inserts so often. Okay, and when you can do that in Dremio, you can do that in Spark, you can do that in Flink. How you land it in Iceberg is fine, as long as the catalog connects to Dremio. And Dremio has a built-in Nessie-powered catalog called Arctic that gives you other benefits like automatic table optimization. So basically, you can move that data into there, and then you get the automatic table optimization. So the whole process gets easier. But again, basically, ELT in particular becomes a lot more practical because you can do all the transformations after the data becomes accessible to Dremio, and you can do that all logically. So most of the time you have to do no movement of data, no copying of data. So you're not increasing your storage costs pretty much, and only when you need to, you turn on data reflections. And then once you've exhausted data reflections, then you explore like, okay, landing the data directly into Iceberg to get just that extra crispiness. But again, you're able to do that and then Dremio can capture the lineage of all those transformations through logical views in its UI. So it gives you all the tools to really make ELT powerful. But also, if you're doing ETL, Dremio is still great because you can still curate all your data, do all those transformations when you land your data in your data lake, and Dremio is still going to provide you best top-notch performance when it comes to querying the data lake, and then give you those tools like data reflections to squeeze out even better performance and the ability to federate that data with other data you may have elsewhere that you may not want to land in your data lake. So whether you're doing ETL or you're doing ELT, Dremio is going to offer you ways to save money. And then one last thing I want to point out is the C3 cloud cache that Dremio has. So again, one of those cost drivers that we talked about was access costs. So Dremio clusters, they have this thing called the columnar cloud cache, where as you run queries, it's going to pick up on query patterns and start caching frequently accessed things on the nodes. The result being is that you're not making as many calls to S3 or to Azure. So not only are you reducing your compute costs because the queries are going to be faster from the caching, but you're reducing your S3 access costs because you're not making as many API calls to S3. So you can see sometimes dramatic decreases in your costs because you're attacking the compute, the storage, the access when you're using all of Dremio's features and optimizations that it has under the hood. Okay, again, really making whichever way you're moving your data, ETL or ELT, very, very manageable. So a lot of times you'll read these articles that really kind of criticize ELT, because they're imagining that scenario where you land all your raw data in your data warehouse and you're paying for that extra expensive storage and using that extra expensive compute to do all your transformations. But ELT can be a very valuable pattern when you're using tools like Dremio that don't necessarily aren't going to surge your costs. Okay. when you use sort of the way, when you take advantage of Dremio's particular architecture with that particular pattern. Okay. Now, just a summary of what we're talking about. Again, basically with Dremio, you have a zero copy logical view first architecture. So again, at the end of the day, you initially don't have to make any copies. When you need basically when warranted, because again, the performance should be pretty good up front, but when you need a little bit more, you turn on data reflections and Dremio will manage that. So essentially the data reflections is almost like turning on a data pipeline without you having to design it. It'll just automatically handle the movement and syncing of data. Okay. And then, now if you're moving like data from like an iceberg table to another iceberg table, you now sort of have like incremental processing that's built into all of that. So the reflections will update incrementally. So then even better performance, faster, crisper, freshness. Okay, less data movement, again, lower compute costs, less storage costs, especially when you're doing that ELT. And in this case, we're even taking out the export part because you're just connecting the data directly to Dremio. The columnar cloud cache, that's going to lower those cloud access costs. Data reflections, which creates those reusable physical representations built in Iceberg that can be partitioned and sorted to your specification. And you can actually build multiple reflections for the same data set. So if I know there's two sort of categories of queries that are on the same table, I can create two reflections, one that's optimized for these queries and another one that's optimized for those queries. And then Dremio's cost optimizer will know which reflection to use based on the query. So that way, again, you're reducing those compute costs. And again, it won't necessarily recreate the entire table. Dremio will create like pieces of reflections so that way you can mix and match them. So that way you get sort of like the best bang for your buck. It makes them very modular and reusable. And they're reusable across multiple views. So any views derived from a particular table, they get the benefit of those reflections as well. And I'll talk a lot deeper about reflections in I think next month when I'll do a presentation on reflections in particular. Okay. You can denormalize among disparate sources. So again, if you want to do denormalization, you can do that through logical views on Dremio, and you can do that across multiple sources. And then again, you can always just turn on reflections on that logical view to create that physical representation. And essentially, again, you've just literally, in a sense, kind of turned on a data pipeline at the flip of a switch because Dremio is handling that. Okay, periodically, let me go back to run these queries and recreate that physical representation. Okay. The semantic layer in Dremio is going to allow you to document, govern, and monitor data. So earlier we talked about monitoring as a best practice, particularly for like ELT. Well, Dremio is going to, again, provide you with lineage built into the platform. It has all types of governance, role-based access governance, column and row masking rules. So you have robust control over who has access to what data. So that way you can have the raw data there and not have to worry about people having access to the wrong data. You just make Dremio sort of the central access point for your data, regardless of where it lives. And then you have DremioArctic, which is a catalog. So essentially, if all your data is sitting in Iceberg using the DremioArctic catalog, and you wanted to give somebody access to a copy of the environment, normally what you would do is you basically create a copy of the data and say, okay, here's your copy of the data that you can play with that won't affect my copy of the data. But now you're duplicating your storage. But with DremioArctic, you can literally just create a branch because it has like those Git-like functionalities. And that branch does not create a copy of the data, but any changes to that branch do not affect the main production branch that everyone else is querying. So you can create these experimental environments for other people or other teams without necessarily having to duplicate your data. So Dremio really does a lot to help reduce the need to copy, which again lowers your storage costs, but then also through caching, through data reflections, and then just a overall super fast engine, you get the reduction of compute costs and better performance, and also just the semantic layer that provides a very easy interface for your end users. Okay, so it just makes getting the data into your data lakehouse easy. It makes it using it in your data lakehouse pretty easy. Okay, so hopefully you guys enjoyed this presentation. Again, my name's Alex Merced. You can follow me on Twitter at @AMDataLakehouse. And again, subscribe to any of these podcasts over there and ideally all these podcasts on Spotify and iTunes. And now we're going to be getting into Q&A. So I'm going to go take a look at the chat and the Q&A box to see what questions people may have. Okay. And I see there's a question to share the QR code again. So let me go back to that slide so that way you guys can see that. There we go. So I'll leave that up for anyone who wants to take a picture of that. Okay. Okay, so here we go. So basically why Dremio's Lakehouse storage is cheaper than a data warehouse. Okay, so the online is generally, if you are using like a data warehouse, oftentimes the storage in the data warehouse is marked up. So you may be using S3, but when you're using Snowflake's S3, you're paying the Snowflake price per se. Okay. And I'm just using that as an example. There's other warehouses. Choose whatever warehouse. And same thing on the compute side. Okay. Now, when you're using a data lakehouse pattern, and again, that's any lakehouse pattern. Just basic idea is that basically you're now landing your data and keeping it sort of specifically and doing all your analytics from the lakehouse directly from your own, let's say, S3 storage or from your own Azure Blob storage instead of using the data warehouse's storage. Then you're paying just sort of like those raw storage costs. You're not paying a markup on that. So that's one level where but that's a data lakehouse that makes it cheaper. Okay, where Dremio makes things cheaper is that it reduces the amount of copying that you need to do on one level through the data reflections, which is another question about data reflections. So I'll explain that more in a moment. Through all these different levers that Dremio has, it makes the need to copy data and create, but still have multiple versions of the data much easier. Okay, and so it saves you the cost on storage. Dremio's engine is very performant, mainly because it's based on Apache Arrow. It has a lot of other really cool under the hood tools. There's actually a really good video from our most recent Subsurface conference called something about like 1,000 how to run thousands of concurrent queries on Dremio, where one of our essays goes through a scenario where they had thousands of concurrent queries running performantly on Dremio and sort of the architecture behind it and what enabled it. Really goes through a lot of the performance optimizers in Dremio. I'll make sure that's a link in the follow-up email. And also the C3 columnar clash, that's going to reduce the access cost because you're basically caching Parquet files or micro blocks of different things, so that way you're not having to repeatedly access them from S3, and it's also just faster to access them right directly on the node. And then you have data reflections, which are kind of like materialized views. I'm going to do a whole presentation trying to outlining the differences between materialized views and data reflections. But data reflections, essentially what it is, if I turn on data reflections on table A, let's say, essentially what it's going to do, depending on the detail, it will create a physical iceberg version of that table. Okay. In my storage, in my data lake storage, so in my S3, and it will be partitioned the way I specified, sorted the way I specified, but then that will be used for queries on that table to speed it up. And if I create views from that table, that reflection will also be used to speed up any queries on the views. So it's not like materialized views, which are matched by namespace. So basically, if I have two views on the same table, each of them would need their own separate materialized view. Here you have a materialization that can be used in multiple different levels. So you reduce the amount of materializations you need, again, lowering the amount of duplication of data you need. But also it's automatically synced for you. So generally, like you can set a schedule. There's settings you can change, but I think like the default's like every 5 minutes. Every 5 minutes it will go like, or periodically we'll go in there and then resync the data. So essentially it will go check to see if there's any updates and then update the reflection. So that way it's using the reflection to speed up those queries. Okay. Thanks for the work. How can I compare the main branch of my iceberg data and the dev testing branch in order to detect data changes? Is in your queries, you can specify what branch you're doing. So one thing you could do is you could just do two select all statements, one querying the table from one branch and one querying the table from another branch, and then just do like a union all kind of thing and get the difference between the two. And then basically you'll see the differences between the two tables as far as like the actual records. Okay, if you want to see like sort of like the difference in what Parquet files on your storage, what you can do is you can use the iceberg metadata, and you can actually query the list of files that are part of the table at a particular currently, and then you can do the same thing where you do one select all query for all the files in table A, and then select all for the same thing but table A in the branch, and then do like a union to kind of discover their differences. So, and you can do that all in a single query right there from the Dremio UI. So it's pretty convenient because, again, in the query, you can specify what branch you're querying and you can run multiple queries, whatnot. Okay. And then also, I mean, another note is that you'll know if there's data changes because basically you do have an audit log for your DremioArctic tables. Okay, you can go to the DremioArctic UI and you can actually see all the commits and you can see who made the commits. And generally there'll be a commit message that kind of gives you an idea of what was changed. So basically, if you see no new commits, you'll know there's been no data changes. And then if you do see new commits, and then you can kind of investigate further from there. So you don't necessarily have to go create the query right away. You can take a quick peek at the UI, take a look at the commit history, and then decide whether you want to do further investigation. Okay, hi there. I have missed most of the session, but want to catch up with the rest of all the beneficial information you shared. Can I get the recording session? Yes, the recording of these episodes are always posted on Dremio's YouTube channel. That's youtube.com/Dremio. Within 24 to 48 hours from the broadcast, it will also be posted as an episode of Gnarly Data Waves on the podcast, which you can subscribe to on Spotify. I was only able to join now. Will the recording be shared later? Okay, I just answered that question. Again, subscribe to Gnarly Data Waves on Spotify or iTunes. Okay, so you can always find all the previous episodes there. And so this episode will be posted there. And again, also on the YouTube channel, youtube.com/Dremio. And I've also just posted several really cool videos on the Dremio YouTube channel over the last week or so, including one video where I show you how to build a little lake house on your laptop. So that way you have this little laptop environment where you can practice and try things out. So check all that out at youtube.com/Dremio. But with that, I think, let's see here. Do I see any other questions? And yeah, so I think that's all the questions. Again, thank you all for coming this week. Again, come again next week. So for those of you interested in when I was talking about DremioArctic and the branching and the merging, next week we'll be talking about DremioArctic on next week's episode. So be there to catch that. And then again, we have so many more episodes coming down. So you can always just go to dremio.com/gnarly-data-waves to see what episodes are upcoming and register for them. And again, all the episodes will always be on the podcast and on the Dremio YouTube channel. So you can always just subscribe there to make sure you're always aware of what's coming out. And thank you guys very much. Have a great day, and I'll see you all soon.